once you get signed in, and I know sometimes it takes a little while, okay, I need you to go to Google Classroom. Okay, and in there you'll find obviously Science 10 AP, and you'll find that this morning, okay, I had a announcement scheduled to post, which includes all the stuff you're going to need for this lab, including what we're doing today, which is the Prelab. All right, so you can access that either through the stream by clicking on this or going to the class work tab and opening it up as well. Okay, now you'll see in there that there are a number of things. There's a PDF document. Right, that's just the lab sheet. Okay, you can have that open and refer back to it. It's fine. Okay, it's what I'll have up on the board. And then there's a couple of YouTube videos. There's one that is the pre-lab stuff, which is what we're going over today. Okay, so it's just a recording of it from last semester. And I'll probably replace that with what I'm doing right now. And then there's also an observations video. Okay, you don't need to watch that unless you missed the lab. Okay, or if you're looking at your data and going, I'm not too sure about these ones, just watch the video and double check, okay? Because I have exactly the same stuff that we're going to do on Monday. I just have a recording of me doing it. It'll have all the observations that you would need to fill it in, okay? So if that happens, or you just want to double check and feel better about it, totally, that's what it's there for, okay? So absolutely, you can do that. All right. The other part of it is the your work part, and that is the Google Doc. That's what you're going to want to have open right now. Okay. So if you click on that, right, you will get this, which I think I showed you yesterday. Okay. So you've got all these things set up. The format is already there for you. We're going to talk today about what are we putting in here. Okay. So I'll give you some big juicy tips and hints. Okay, you just have to kind of put it in your own words and fill it in as we go. How much detail should you have?
Lots.
Yeah, you should have lots. Okay, you're getting an entire class period today to work on this stuff, so okay, make sure you fill in lots of detail as we go along. Okay. So the problem that we're investigating here is basically how we can identify unknown materials using their physical properties. Okay, so when you're making your problem, remember it needs to be in the form of a question, and it basically needs to say something about how physical properties could be used to identify unknown materials. Okay, what I've got up here is probably a little bit wordy. Okay, don't copy what I have, it needs to be in your own words. Okay, but the problem I wrote in there was, given several unknown samples, how can we classify them as ionic, molecular, acids, and bases in order to find their identity? I think that's a little wordy. Okay, as long as you have something about how can you identify unknowns and talk about physical properties, that would be good. Okay, something along those lines for the problem. Okay. And guys, I probably won't give you enough time to type everything in as we go along, so you might just want to type in a note or two, or maybe write a note on paper, and then you can fill it in when we got the class time to work on it. Okay. The next part is identifying your manipulated, responding, and controlled variables. Okay, so when you're looking at your version of this, okay, it just says manipulated, and then there's blank, responding, there's blank, controlled, there's blank. We're going to fill that in now. Okay, so in this lab, the procedure is going to kind of go a bit like this. You're going to have a whole bunch of unknowns, okay, and you're going to run the same battery of tests on each unknown. Okay, so you're always going to do the same tests all the way along, but each time you do the tests, it's on something new. It's on a different material. Okay, what we're watching for is the response of that material to those tests. Okay, so what are we manipulating in this experiment? The material. Okay? We're running the same tests every time. We're watching for the results of those tests. Okay? But the results of those tests responds to what I tested. Okay? So in other words, I'm manipulating the substance being tested. Okay? So I'm giving you this, and I'll do that on this lab. I'll tell you what it is. You've got to word it correctly. Okay? So the manipulated variable here is the unknown materials. you need to explain to me two things. How is it being manipulated, and why? Okay, so that process that I just talked through a minute ago, that's what you're gonna have to do on every lab in order to determine what's my manipulated, what's my responding, and what's my control. So I'm gonna walk you through it again, so you can kind of get an idea of what you're looking for here. Okay, so in this lab, what's happening is a battery of tests, the same battery of tests, is being run on a new material. Okay, there are 11 materials. Okay, each time I run the battery of tests, it's on a different material or a new material. Okay, what I'm watching for each time I run that battery of tests is basically the results of the tests. Now the tests are testing for, or supposed to reveal to me, the physical properties of that material. Okay, so I have a new substance. I run this set of tests, and I get physical properties. So what's my responding variable? The physical properties. Okay? They are the result of what I am doing, and they are different each time I test a new material. Therefore, they respond to me changing the material. Okay? That's what makes it a responding variable. Incidentally, I just kind of gave you the explanation also now for the responding variable.
For control, should we also talk about like the room's conditions, like temperature and stuff?
We'll get to control, but yeah, you're on the right track there. Just in walking around and looking at a few screens here, guys, quick reminder. This is one of the few things I understand from English class. What person should this be written in?
Objective, third.
Yeah, third objective person, right? We want to try and avoid I or we or, and that's easy to do in the manipulated part, right? If we're going to change the material, that is what we are going to do, but it's better to say the experimenter will, and that removes you from the experiment. Okay, I know that seems like a nitpicky thing, but science can be a little nitpicky sometimes. All right, so we've done the manipulated and we've done the responding variables now. Okay, so controlled variables are things that need to be kept the same throughout the experiment. Okay? In this case, they could be things I would want to do the same each time I test a new material. Okay? Now, controlled variables can come in two types. And it's always good to have, I mean, you have to name 3 controlled variables, but it's always good to have, okay, at least one of each type. Okay, you're probably going to have 2 of one type and 1 of the other. But here are the 2 types. The 2 types of controlled variables are conditional, sometimes also called environmental, and procedural. Okay? Procedural controlled variables are controlled variables that have to do with your method, okay, and what you do in terms of how you run the experiment. Conditional controlled variables have to do with the conditions under which you run the experiment. Okay? Those could be things like temperature, okay, time of day, things like that are conditional controlled variables. Procedural controlled variables would be things like, these are my tests, and I'm running the same test every time, except we don't use I'm in there. Okay? Or the order in which the tests are run. Things like that are procedural controlled variables. I would want to make sure I do those the same way every time for consistency.
Would humidity count as a condition?
Yeah, absolutely. Anything environmental that could affect the results of the experiment should be controlled. Okay? Like for this experiment, I don't really have to worry about whether the lights are on or off, other than convenience. Okay? There's probably enough light coming in through the window for me to do this experiment without the lights being on. That's a conditional control variable. It's kind of irrelevant for this time. Okay? All right. So if we're thinking about controlled variables, we have to name 3, and we have to say how they're being controlled. Okay? And for a conditional variable like temperature, you know, that's pretty straightforward. The thermostat will be set at room temperature and I won't change it, okay, or it won't be changed throughout the experiment. Or you could have, so that would be the how, and then the why, you gotta tell me why does temperature need to stay the same throughout the experiment? What does it affect? Okay, what's one of the tests we're running that could be affected by temperature?
Like how fast it dissolves in solubility.
The solubility test, absolutely. It would be important for me to make sure that the samples and the environment stay at a consistent temperature so it doesn't throw off the solubility test. Yeah, and it could, I mean, probably in the range of temperatures that could be possible in that room, not this room, because this room can change by almost 9 degrees in the course of a day, sometimes 10 or 11. Okay, but in that lab, the temperature typically doesn't change very much, certainly not enough to make a difference for the melting point or boiling point of anything we're dealing with. Okay, but I mean, in some places, yeah, that would be very important. All right, so you need 3 control variables, and each one's explanation, how it's controlled, and why. The why is, what effect would it have if you didn't, or how could it affect the experiment? Okay, the control variables probably take the longest to do because you have the most to think about. All right, so I'll give you guys a couple minutes to do some typing for your controlled variables. All right, so for the hypothesis, okay, in our hypothesis, we want to use what 3 words? If and then. Remember, our hypothesis needs to be a deductive statement. Okay, if this is true and an experiment like this is performed, then the results will be this, or then this will be accomplished. Okay, something along those lines. All right, so the if part of your hypothesis is the premise that you are testing or working from. Okay, in this experiment, the premise we're working from is that all materials have unique what? Have unique physical properties. Okay, that's the premise we're working on. So the if part of your hypothesis needs to talk about that. Okay, it needs to talk about the fact that you believe, okay, but you don't write I believe, okay, that the premise that you're working on is that all matter has unique physical properties. That's, if that's not true, does this experiment work?
No.
It doesn't. Okay, that's how a hypothesis works. We're trying to see if that's true. Okay, so that's the if part. Okay, all materials, or all matter has unique physical properties. And what determines those physical properties?
Atoms.
Yeah, the atoms, the elements, the numbers of protons, okay, all that kind of stuff. Not a bad idea to maybe work a little bit of that in there. It was in lesson 1, okay? What we talked about was the number of protons that determined, okay, the physical properties of a material. If you wanted to have a really thorough hypothesis, that's not a bad thing to work in there, okay, into the if part of the hypothesis as well. Okay? The gist of it though is that unique physical properties of all matter idea. Okay, the and part of our hypothesis is supposed to do what?
Briefly explain the experiment that we did.
Briefly explain the experiment. Okay, so in this, we don't want to have a whole procedure in there. That's what the procedure part is for. Okay, in this part of the hypothesis, we just want to kind of give them an idea of what's going to be done. Okay, in this experiment, several unknown compounds are going to be subjected to various tests to reveal their physical properties. Okay, I don't have to say, necessarily which tests. It's not bad for me to say, observable properties, solubility, pH, okay, aqueous conductivity. I mean, after all, I'm really only testing a few things. It might not be bad to name drop them, okay, slightly in the and part. Okay, but that's what the and part's role is. Briefly describe what you're doing. Okay, tests are being run, name the tests if you want, okay? Tests are being run on unknown materials to reveal their physical properties. In your own words, something like that is what we're looking for, okay? So. All right, last part of the hypothesis is the then part. Okay? The then part of the hypothesis explains what you are going to see, what your results might be, and to an extent, what you might be able to do with those results. Okay? So, if all matter has unique physical properties, and tests are being run to reveal those physical properties, then, okay, each unknown should, okay, you gotta talk about it there in the then part, okay? What's gonna happen? What are your results gonna be, and what are you gonna do with them? Okay, so after you've run all these tests, you're gonna have some observations for each unknown, okay? What are those observations gonna look like? Are they gonna be different for every one of them, or are they gonna be the same for every one of them? And what are you gonna do with them? Okay? Spoiler alert, we're trying to identify the unknown materials from said results. Okay, so that should probably go in there somewhere. I would say that we should talk about what the results would be, I don't know what you're gonna be able to do with them, but just a brief description of the piece of what each one have, a unique set of data. Yeah. All right. After the hypothesis, okay, we've got our list of materials. You don't have to do anything with that list of materials, okay? It's just there for you. Remember that in that list of materials are the identities of your unknown compounds. Okay, so one of your unknown compounds is ammonium nitrate. Okay, one of your unknown compounds is copper 2 sulfate. Okay, and so on and so on. All right, so what's not a bad idea, okay, is to kind of brainstorm what are the properties of that compound going to be. Okay, and it's not, you know, cheating to Google that at some point if you really, really feel like it. Okay, if you Google, you know, physical properties of copper 2 sulfate, they'll probably even come up with a picture of it and you'll have a pretty good idea of what you're looking at. That's fine, that's not cheating, that's just being resourceful. Okay, the internet is there for you. Just don't always trust it. There's some really crazy stuff on there. Okay, the purpose of the rest of today is for you and your group, and I'd like to keep the groups at 4 or less, and I will let you pick them, okay? Keep in mind here, guys, that if you see someone who, you know, needs a group, to welcome them into yours, okay? It's always good to be, you know, inclusive. So what I want you guys to do with the remainder here is, as a group, come up with your procedure. Okay, now we talked a little bit about the tests that we want to run yesterday. I'll go over that again today. But your procedure needs to include everything, right? Like, what's the first thing you're going to do when you walk into the lab? Goggles, okay, and possibly a lab apron. Right? Once you have all that stuff on, then what are you going to do? Okay, then what are you going to do? Get the materials you need. Where are they? They'll be on the front table. Okay, so I'm telling you that so you can put that in your procedure. Okay, get required materials from the front table. Okay, and then you got to start talking about, all right, how much are you putting in each depression? Okay, all of those little nitpicky details, okay, we'll talk about a little bit more here, but that's the kind of stuff that you're going to need to brainstorm with your group. Okay, what tests are you running? That's not really a brainstorm, we're going to say that, we know which ones. Okay, talk about how you're going to run them, what observations are you going to want to make for each one. Okay, now you're testing 11 different materials. Do you need to do that set of steps that talks about running the tests 11 times? No, I've had people do that and their lab reports end up being like 20 pages long. We don't need that, especially since it's repetitive. Okay, so you could have the instructions for the tests and then say, repeat steps 4 through whatever for all unknowns. Okay, and then they can just go back and keep doing it. Okay? Does your procedure need to be a numbered list?
Yes.
Yes. your procedure must be a numbered list. Step 1, step 2, step 3. Here's why. I have people who put it in paragraph form. You are going to get lost if you're doing that. You can go, hey, I'm on step 4, walk away, come back and find step 4. But if it's in a paragraph, where in the paragraph was I? Well, I get to start the paragraph over again each and every time I leave the table and come back. Okay, that is really inconvenient, right? So it does need to be a numbered list.
Can we write it like bullet points?
Numbered,
Yeah.
not bullets, okay,
Yeah.
it's just dots.
But like separate lines for each one. So
Yeah,
like-
oh, yes, definitely, please, it should be, yeah, like, just click the numbered list part of the, Google Docs, okay? So that's what you and your group will be doing today, is getting the procedure put together, right? There's already an observations chart, okay, in there for you. In your Google Doc, it looks like this, okay? So compound A, observable properties, and you might want to change the size of these, okay? Conductivity and pH, the only observation you're making there is a number. Okay, so those columns could be a lot thinner. Your observable properties, you could be writing quite a bit in there. Okay, and for your solubility, it's not a yes or a no, right? You're going to be writing in there, did it change color? Did the temperature increase or decrease? Okay, all of that kind of stuff. So, you know, you've got a few things that you probably want to write in there. So I'd say observable properties probably needs to be the biggest of the columns. Solubility, the second largest. Conductivity and pH can be very small. Okay, and even the compound one can be shortened a little bit. It's just that's the way it built it. Okay, so you guys can mess around with that if you need to. Okay, let's talk about the procedure. So yesterday we brainstormed. We brainstormed a few. Come here. We brainstormed some of the tests that we're going to run. Okay, so we said the first test we want to run is the observable properties test. Okay, and in that test we wanted to look for these things. We wanted to record things like color, state of matter, okay, the nature of the matter. Was it crystalline? Was it waxy? Was it liquid? Okay, those kinds of things. Okay, odor test. How did that get spelled without a U? That's shameful. Odor test. Okay, so wafting, okay, and does that need to be part of your procedure? Okay, don't just go do odor test. So what? Somebody goes, I'm good. Okay, no, that's not, okay, you want to walk up there and right, waft, tell them to waft it, okay, tell them to hold it, you know, a ways away from their face, okay, things like that. Those are all little details that are important in a procedure, all right? Then you want to run the solubility test. Okay, and again, in here, we want to have things like when you're putting that material in the depressions, how full? How much do I put in? If I'm doing a solubility test, yeah, I'm going to fill it to about 2/3 to maybe 3/4 with water. How much of the material do I put in the bottom? Just cover the bottom. Okay, those are details that need to be in there. Otherwise, someone's going to dump it in and fill that thing right to the top, and then what do they do for the solubility test? Okay, you got no room for water. Right, so little details like that. All right, so in the solubility test, again, tell them how to do it and tell them what to look for. Okay, dissolving means there could be a temperature change, it could be a color change, the material could change shape, shrink, or disappear entirely. Right, tell them to look and record those things. Right, the worst thing you can do, guys, okay, is to have your procedure be get stuff, put goggles on. Put stuff in holes, add water, stir, do conductivity test, do pH test. If that's your procedure, you're going to get a resounding 1 out of 5. Okay? Because that lacks detail. Okay? It needs to have detail in each and every step. Okay? How to do it and what to look for. Okay, for the conductivity test, okay, again, you're going to put the conductivity tester in, press the button, right, and you're going to record the number, you're going to rinse it with distilled water before you put it in the next one. All of those little things are important details. Okay, pH strips, place the pH strip in the solution, check the color against the code on the bottle, okay, those kinds of things. Should cleanup be part of the procedure? Yes. Because if you just write your procedure and you don't have cleanup and you walk out of there and leave a mess for me, I guarantee you're going back in there. Okay, so make sure you have cleanup, okay? Once you're done, everything should be cleaned and drop it, okay, with paper towel. Right, and then put back where you got it from, and then wash your hands, put your goggles away, okay, all that kind of stuff. All right, all of that goes into the procedure. Are there questions on the procedure? Okay, so we've got what here? Another just about 20 minutes, okay, for you to get together with your group and start writing up the procedure. We do have some time tomorrow as well. Okay, so if you don't get it done today, don't panic and go home and work on it tonight. We've got some time. I've got the Chromebooks booked again tomorrow. All right? Questions from you guys? Okay, have at it then.